In this lesson, we're going to examine a second type of interest, one that's used more in the real world, the practical sort of situation here. We call it compound interest. Compound interest builds differently than simple interest. Simple interest, you make your calculation at the end of your time period. You put your money in at a certain rate for however long it's in there, you make one single calculation. Compound interest, on the other hand, makes multiple calculations of interest over time. So for example, let's say we had $100, we're going to invest at 5% for 5 years. Simple interest, we'd have our one single calculation at the end of 5 years, and we'd end up with $25 in interest. So we end up with a total of 125. The 100 we start with plus the $25 in interest. Compound interest, on the other hand, we'll start with $100, and we're going to calculate it at the end of each year. So after 1 year would make 5%, which is $5. We'd have 105 now. But to start the next year, we're now starting at 105. So when we're calculating our interest, we're actually calculating interest on top of interest. So if we did 5% of the 105, we'd have $5.25 for that year. We're up to 110.25. That would be our new starting point. And you calculate 5% again, you get $5.51, and you're up to 115.76. And you can keep doing that, where you're reinvesting your interest and calculating interest on interest. And at the end, you're not going to have a huge difference. Okay, if we go to the 5 years here, the last year we get $6.08. We'd be up to $127.63. And I said it's not a huge difference, 125 to 127, but the fact of the matter is you haven't done anything differently except for make more calculations. So it doesn't hurt you, it doesn't cost you anything, it just happens more often. So if you take a look at compound interest, really the way it works is simple as a linear relationship. It builds the same amount every year. Compound builds exponentially. So it's going to start off very similar to the simple one, but then it's going to start building faster and faster and faster. If you notice in our previous example, by the 5th year, you're making $6 in interest instead of your usual 5. If you do this for 20 or 30 years, you can imagine how fast this amount of interest would build. Our formula for compound interest is slightly more complicated than simple interest. We've got a few more letters here. So FV is our future value, how much we end up with, the amount. PV, that's our principal, our starting amount. R is our rate, and again, we're going to divide it by the 100 like we did yesterday. K is a new letter for us. That's our compounding period. That's how often you're going to make your calculation. Notice that K shows up in 2 separate spots. It shows up down here, so it tells you how often or how much you have to break your interest rate up by, and also up here, how often you're going to make your calculation. And then we have N again, and N is our number of years, how long we're going to do this investment for. Okay, a little bit more about compounding period. So there are a variety of compounding periods that we could have, how often you want to make that calculation. The ones that are standard are annually, so you make it once a year, like in the first example we did. You could do something semi-annually, every 6 months, or half-yearly, that means you do it twice a year. Quarterly, you would do it 4 times a year, every 3 months. Monthly, at the end of each month you make a calculation. Weekly, daily. We're going to come across those 5 situations often. You won't see daily too often, but you could come across that. All right, we're going to try an example. So we have $1,000. We're investing it for 3 years at 12% compounded annually. This is how you know it's a compound interest question, because you see the word compounded. Determine the amount when the investment matures. So we want to know our future value. We know our present value is 1,000. We know our N is 3. We know our rate is 12%. And we know our compounding period, how often we're calculating, is 1. So our FV will equal PV, 1 plus our rate, 12%, 100 times a 1, 100 to turn into a decimal, and the 1 is our compounding period. And we're going to do it once a year for 3 years. Now you can punch in your calculator just the way it looks, or if you want to, what I often do with my calculator, I just change 2 numbers into, oops, not 1,000, 100. 2 numbers into easier versions of them. and put that in my calculator using the brackets and everything. And if we put that $1,000 in and we invest it, we should end up with $1,430.77. Okay? And a series of examples here today. Example 2. Inga borrows 4,500 euros for 2 years. Bank 1 charges compound interest, 15% per annum, compounded quarterly. Calculate the total amount to be repaid at the end of 2 years. Okay, so her present value was she borrowed 4,500 euros. Her interest rate was 15% per annum. That's her yearly rate, but it's compounded quarterly. So we got divided by the 4 down here. We're going to do it 4 times a year for 2 years. Again, I will simplify it just a little bit to make it easier to put in my calculator. And I end up with Inga having to owe $6,041.12. And notice this is our amount. We're not calculating interest. To do interest, you have to figure out the difference between what you started with and what you ended with. Part B, Bank 2 charges simple interest. She would repay the same total amount as for Bank 1. Find the rate of interest that she's charged. So, using simple interest, I could use the CRN formula. I need to know my interest. How much did I start with? Or sorry, how much interest was paid? So our interest will be, as I was saying, the difference between what we started with and what we ended up with. So she had to pay an extra $1,541.12 in interest. Okay, so we want to figure out the rate that she has to pay with Bank 2. So her interest is $1,541.12. Initial value is $4,500. Her rate we don't know. Her time we said was 2 years. And we're going to divide that by 100. That's our formula. Okay, to make it a little bit easier to work with, we'll do all the math on the right-hand side. 4,500 times 2 divided by 100 makes 90. With an R attached to it. Divide both sides by 90. And we get 17.12%. Okay, if you want to go 3 sig figs, 17.1 would be the most appropriate. Try the third one. A GIC, it just means a guaranteed investment certificate. It's a type of investment. Compounded quarterly for 3 years. The money is going to be then reinvested in a mutual fund, another type of investment, for 5 more years at 3%, compounded monthly. How much interest will initial $1,000 earn? So let's try the first investment. Our future value, we're going to start at 1,000. 1 plus 6.75, 100. We're doing it quarterly, so 4. We're doing it 4 times a year for 3 years. So 1,000, 1 plus 6.75 over 400 to the power of 12. That will accumulate to 1306.05. We're then going to reinvest that money. So our new future, our present value is that new starting point, 1306.05. And we're going to do it 1 plus. Now we're doing it 3% monthly. So 3% monthly. That's a power dividing by 12 for a compounding period. And we're going to do that 5 years at 12 times a year. So a better version of that, 1 plus 3 over 1,200 to the power of 60. If we put that much money in there, we end up with 1594.68. The question was, how much interest will she earn? Her interest, her I, will be the difference between what she started with and what she ended up with. She started with 1,000, so if I subtract that from her end, we can end up with $594.68. Okay? Last idea. Sometimes we want to know, what do I need to invest today in order to have a certain amount in the future? I want to save for something. Well, I don't need to save all of it today. If I'm allowed to accumulate interest, I can save less than I need, allow the interest to build up, and then I have the amount I want. We call this the present value of an investment. Okay. The present value is basically, we'll find this a PV. We know the FV, Everything else stays the same. We just need to find the PV. So what we can do for this is we can actually rearrange our equation. So if we're looking at this example here, we have Trish. She wants to buy a car when she graduates from high school in 4 years. How much would her parents have to invest now to afford an $8,000 car? So to find our present value, we can take our future value, and instead of having the brackets over here and multiplying together, we can bring them to the other side and actually do some dividing. So R over 100K to the NK. So we can get rid of the multiplying and turn it into dividing. And basically works the same way otherwise. So for Trish, her present value, what does she need now? She wants to end up with $8,000. She's going to divide that by 1 plus 8.5% as a rate. She's compounding semi-annually, so it's K of 2. She's going to do this twice a year for 4 years. Again, I'd probably simplify this, put in my calculator. So 8,000 over 1 plus 8.5 over 200 to the 8. Put it all in your calculator and you should end up with 5769.34. She's going to accumulate over $2,000 in interest over that period of time. That allows her to save a lot less now, but still end up with what she needs to. Kind of a handy thing about compound interest. You don't need nearly as much as you need in the end to start with. Okay, some questions you should probably try about compound interest. We're going to look at some things tomorrow also with compound interest, solving for N, solving for K, solving for R. But you kind of need to be okay with future value and present value first of all.